Great. Hello, everyone. I'm Li Wenhan Xie. I will present WaitGPT. This work is done with my brilliant co-authors Cheng Bo from HKUST, Haijun from UCSD, Hua Min, my advisor, and Zhu Tianchen from University of Minnesota. Well, this is a long title. We aim to monitor and steer conversational LLM agent in data analysis task, and our system features code visualization generated on the fly. Voila, this is WaitGPT. When LLM generates code, there will be an additional panel with simple visualizations telling you what's going on in this code. So you can follow it and say, wait, what? No, stop. So that's the idea. And let's take a step back. Before WaitGPT, there is ChatGPT, right? And other tools like Gemini. This is ChatGPT's UI half a year ago. To do data analysis, users upload data and initiate instructions. And LLM will try to synthesize code, execute it to see the result, and perform analysis. A conversation may compose of multiple code generation for drilling down exploration. But as LLM knows not much about the data and it generates free-form code, it's highly possible that the code is not reliable. And here we see error. Anyway, the result is 11 to 15, but actually it should be 6 to 10 if you look at the previous visualization. And the reason is that it used a dictionary sort because it doesn't know its string values. So to learn more about how actual users of ChatGPT or other tools feel like on this new scenario to do conversational data analysis in LLMs, we did an interview study with 8 volunteers who are quite experienced in conversational data analysis. So turns out many people shifted from traditional software like Excels to LLMs, as LLMs can flexibly address their data consumption needs and help them verbally describe their tasks. But they are pushed back for some common reasons. This includes a disrupted workflow where they need to wait for a fairly long time during code generation, analysis generation, etc. And looking at the unfamiliar code generated from machines is not natural to them. They need time to get accustomed. And the iteration can be back and forth. If they articulate what they want, they may not see the result that they want, and it concerns multiple iterations. And here summarizes some common mistakes made by LLMs in their generated code. So when designing WaitGPT, we try to abstract code stream into key operations and scaffold LLM analysis with on-the-fly visualization and help them to focus on the visual representation instead of the raw code and allow them to iterate with the interactive viz instead of interact with the raw code. So let's look at previous work. Recent works have looked into enhancing user steering in LLM-powered data analysis, of course. The left one surfaces the runtime output with rich information layers for post-generation verification. And the right one, presented by Maji yesterday, introduces breakpoints to steer the assumptions, plans, and code before executing the code. Different from their target stages, we try to support real-time steering along with the code generation process instead of the post one or the before one. And you may be aware of some excellent works in code visualization or data script visualization, like Datamation that shows the change of data, and Pandas Tutor that links operation with the results table. And Unravel allows step-by-step examination during user interactions of individual code cells. But WaitGPT targets LLM-generated code, which has some new features. One, it may involve multiple tables. That's not a quite common assumption in previous works. And they produce mostly reliable in syntax with proper comments, and the code is generated by token in streams. All in all, we ask in this work, how can users proactively monitor and steer the data analysis process conducted by LLMs? And our solution is this WaitGPT. And I'll break down its workflow. Essentially, when users post the instructions, LLM generates the code, and now we will parse the stream code into data operations by static analysis, and then execute the code line by line to get some runtime states of the intermediate table, and combine the static code structure together with the runtime table into a visual representation like this. A diagram shows the static structure of the code operation chains and the dynamic runtime in this block-like things. And then users can interact with this representation and tune the code to get the correct execution result and the correct analysis if LLM analyzed correctly. And the diagram looks like this. The orange ones are table nodes, the pink ones are operation nodes, and the gray one are the result nodes. And we have table glyphs, the little blocks that runs along with the diagram during streaming to show what's going on to the table, just inspired by previous works. And here is an example of the visual representation. So in this code snippet, it will be translated into a diagram like this. And actually, the code and the diagram has a one-to-one mapping. If you hover on one block of the diagram, the code will highlight. And when you interact with the block, the context is this specific line of code. Apart from the visual representation, we also have interactivity in these visual nodes. You can inspect the data by clicking and do the granular refinement of the operation parameters directly on the diagram. And also, you can do contextual interrogation. By this, I mean you can hover on a block and directly ask, why do you do this? And LLM, we will use an external LLM to respond to your questions without breaking the order of your previous conversation. So it's more granular. And this shows how you can access details and ask questions based on specific operations. In our evaluation, we do a comparative user study with 12 participants, mostly our graduate students, to learn the effectiveness of WaitGPT. The baseline is a chat-only interface, removing all those visual representations, just follow something like ChatGPT. And we have 10 tasks in the literature, and we will give the participants a given query, ask them to verify the analysis generated by WaitGPT or ChatGPT and correct it if they found it mistaken. And the findings are that WaitGPT mostly achieves a higher or equivalent error identification rate compared with the baseline. And it can facilitate faster error identification if there are errors in the logic chains of the operation sequences. And the WaitGPT condition has significantly lower cognitive load when we use the NASA-TLX questionnaire. We also asked some additional questions to the participants and compare their experience with the baseline. And we found that users gain confidence in the LLM-generated analysis greatly when they're using WaitGPT. And they found WaitGPT facilitates code understanding, verification, and error correction. And they found it enjoyable to simply look at the chart instead of focusing on the raw code. Our participants have different expertise in programming, but all of them hopes to see the visual representation instead of the code. But also there will be glitches because dependent on their expertise, there are diverse user needs in the level of details. Some may want to access more statistical information about the intermediate data table nodes, and some do not want to see so many details. They want to remove the parameters of the data operations. And also there are concerns of the visual representation itself because they are afraid that some detailed parameters are not shown on the diagram. And it's also true in our case. So in future works, you may consider adapted interface tailored to different user needs and maybe generative diagram instead of predefining those visual blocks like we do. And we also want to emphasize that data consumption democratizing is a very challenging work, and we want to make the generative AI steerable in all different tasks with data. So from exploration to explanation, some users just want to clean the data, wrangle the data, do some simple analysis, explorative or confirmative. So depending on the task, the level of details they want to access are different. And we hope to explore a way to let them dynamically get the visual feedbacks on that kind of visual diagram. So takeaway messages. WaitGPT suggests a new scenario of LLM-powered data works, where non-expert users are exposed to data programs. And our design showcases that we can translate LLM stream into animated visualization, maybe in storytelling for close monitoring and steering. And you can support granular magnification in LLM operation chains. So that's all for my presentation. If you have questions, feel free to ask.
Yes, thanks, Shelley, for the presentation.